Hello students, in this video we are going to see about the nomenclature. You know how special or important a naming ceremony is? Like you call it as christening or naming ceremony. Like that you have something as nomenclature for the organic compounds. That's nothing but naming of compounds. The other name for that is nomenclature. Now this nomenclature can be of two types. Okay, the first one is which was started years and years back is the trivial system or the ancient system of naming the compounds. Okay, in the good old days, they did not have any definite pattern or definite rule. That was a trivial system. And very few compounds were found or discovered. Slowly, as the days went by, many compounds came in. And then there had to be a regular pattern. And that is when this IUPAC system of naming the compounds came in. What does IUPAC stand for? As you see here, International Union of Pure and Applied Chemistry. Just like you have SI units for physics, everything what you do, you convert into the SI system. Similarly here, this IUPAC is accepted everywhere. Okay, so we don't give rise to trivial system anymore. We don't use it. But in the place of the trivial names, we get into IUPAC names. However, there are some names we should be familiar. There are some which we need to know both the names. See, supposing you have a name in the school, you are enrolled as somebody. And supposing at home, you are called differently. If a relative comes in search of you, he needs to know what is your school name as well as what you are called at home. If he only knows what you are called at home, will he be able to find out? No. So that's why there are some names which we need to be familiar. Okay, now let's go. So there is no well-defined basis, but then in those days, they had named it based on the source or property. For example, they name a child Asha, because they see a ray of hope in her. Okay, so there is some reason for why they are naming it like that. Kiran, okay, there is some brightness, a ray of light. Okay, so like that, these trivial names come through. Now, when you come to the trivial names, this is methane. Of course, methane is retained even in the IUPAC system. Methane is otherwise called as marsh gas. Okay, why marsh gas? If when you go to the stagnant water, marshy areas, the drainages, you can see bubbles coming up. They are nothing but methane gas in marshy areas. So it's called marsh gas. The next one is acetic acid. In the Greek, acetum means vinegar. Those days, they used to use it as a food preservative and a flavoring agent. Even now, we use it like that. Now, this from acetum came acetic acid. But you know what? The IUPAC name for acetic acid is ethanoic acid. So, we should know this is the same person. Acetic acid and ethanoic acid are the same. Different names. One is trivial, one is IUPAC system. Did you get it? Now we go to formic acid. Formic acid was found initially from red ants. Red ants were called formica. Because of that, it got its name formic acid. But now it is known in the IUPAC system as methanoic acid. Okay, this is ethanoic acid, this is methanoic acid. Come on, now you must be familiar with the CCl4. Wherever you turn to, you go to chemical bonding, you have CCl4. You go to acids, bases and salts or electrolysis, you come across CCl4. How do you learn it there? Carbon tetrachloride. This is how you learn it. But according to the IUPAC system, it is tetra, 4-chloro, so tetrachloromethane. That is the IUPAC name. So these are some of the very few trivial names which we must be familiar with the trivial name as well as the IUPAC name. When you come to the IUPAC system, it's made of 3 parts and always IUPAC names have 3 parts. Okay, there is the root word. We fix up the root word and before the root word comes the prefix. Okay, and after following the root word, you have the suffix. So we are going to see that one by one. Okay, so you see here prefix, root word and suffix. Now let's see what these root words are. And in our syllabus, we have only till carbon 5. So if we know up to 5 carbon atoms, that is enough. Just 5, okay? The first one, if you have 1 carbon atom, the root word is meth. So for example, when you take a CH4, this compound is very familiar to you. What is this? Methane. So how does it start? It starts with the word meth. So why? Because it has only 1 carbon atom. That's why it starts with meth. Supposing there are 2 carbon atoms, it starts with eth. 3 carbon atom starts with prop. 4 carbon atom is bute. 5 carbon atom is pent. Pent you must be familiar, pentagon. Like that, this is pent. Okay, so 1 carbon atom is meth, 2 is eth, 3 is prop, 4 is bute and 5 is pent. These are the only root words that we need to be familiar with. Okay, now we go to the prefix. What are prefix? Something that has to come before the root word. And then we have the suffix which has to follow the root word. Now let's go to the suffix first and then follow the prefix. Suffix is nothing but it shows you the functional groups. You have to see, is there any functional group in this compound? Do we find any functional group? And what are the functional groups? We have very few of them. What are they? The alcohol. Alcohol is OH. Okay. In the organic, we call it alcohol. Don't misunderstand this to be hydroxyl. It is OH. Okay. Aldehyde. Aldehyde will have CHO. Now the CHO could be written like this. C double bond OH. This is the aldehyde. Okay. This also is a functional group. Carboxylic acid. If it's a carboxylic acid, it is C double bond OOH. This is carboxylic acid. Okay. Now, these are the 3 important functional groups that we need to remember. Along with this, we will have a double bond or a triple bond, then the name changes. So, these are the things that would follow the root word. For example, if it's going to be C2H4, this is 2 carbon atoms, so eth. And there is a double bond, so ENE. Okay, so because there is a double bond, we write ENE, and because it has 2 carbon atoms, we start with eth. Okay, so that is ethene. So that's about the double bond and the triple bond. So these are about the functional groups. Now we move on to the prefix. Those are called the substituent groups. What do you mean by substituent groups? In the place of hydrogen, we substitute with these groups. And again, we have very few for us to learn in this syllabus. Okay. Now you go to 2 types of groups. One is the halogen groups or the halo groups and the alkyl groups. When you come to the inorganic compounds, ionic compounds, how do we name them? If sodium and chlorine combines, we change that chlorine as chloride ion. Bromine becomes bromide ion. But here we are starting, or this is going to be the prefix. Therefore, there is a change. We should not get confused. Chlorine is chloro. We start with chloro, bromo, fluoro, and iodo. For example, if we have something here in the place of 1 hydrogen, if we have a chlorine group, we would call it as chloromethane. 1 chloro group is there and it's a methane. It's only substituted. Hydrogen is substituted, and chloro group comes in. Therefore, these will start as chloro, bromo, fluoro and iodo. Okay. The last one is the alkyl groups. What are alkyl groups? They follow a regular pattern, that is with the formula CnH2n plus 1. N stands for the number of carbon atoms. Okay. So in this case, there is only one. Okay. So CnH2n plus 1. Now if n is equal to 1, so 1 into C is C. Okay. 2 into 1 is 2 plus 1 is 3. Okay. Now this is called methyl because this comes from the compound methane. So it is called methyl. If we have C2H6, 2 carbon atom, this is called ethane. Okay. Here again, if we are taking this as 2, it would be C2. H2 into 2 is 4 plus 1 is 5. Therefore, this is called ethyl. This is how we get the alkyl groups. So, from one alkane, if you subtract one hydrogen atom, you get the alkyl groups. So, these are the prefixes, these are the suffix and the root words which we should be familiar before we go into the naming of the compounds. So, if you like this, don't forget to like, share and subscribe to this channel. Very soon we are going to go into nomenclature. Wait and watch.